Hello and good day everyone. My name is Sir Marcy and for today's topic, we will be discussing solving equations transformable to quadratic equations. Before we proceed with our main topic, let's try to recall first how to square a binomial. Suppose we're going to square x minus 3 squared. If you still remember the step, the first thing that we need to do here is simply get the square of the first term or square the first term. We have x squared, so x times x, that is x squared. Next is to get the second term, you're going to multiply the first term and the last term and multiply it by 2. Or that's twice the product of the first term and last term, which means x times negative 3, we have negative 3x times 2, we have negative 6x. And to get the last term, we simply square the last term. We have negative 3 times negative 3 or negative 3 squared, that is equal to positive 9. So the expanded form of x minus 3 squared is simply x squared minus 6x plus 9. Let's have another example. If we're going to square m plus 5 raised to the second power, that is simply again square the first term, we have m times m and that is m squared. Next is twice the product of the first and last term. So m times 5, we have 5m times 2, we have positive 10m. And lastly, we're going to square 5. 5 squared or 5 times 5, the answer is 25. Let's try to have some more examples. Suppose we're going to square 3n minus 4 raised to the second power. So again, we square the first term, that is 3n times 3n. The answer is 9n squared. Then we get, or with that, to get the second term, that's twice the product of the first and last term. We have 3n multiplied to negative 4, we have negative 12 times 2, we have negative 24n. And for our last term, we simply square it. That's negative 4 squared. The answer is positive 16. And last example, if we have the quantity of 2m plus 3 raised to the second power, so we'll have square the first term, that is 4m squared. Then twice the product of the first and last term, we have 2m multiplied to 3, that's 6m times 2, we have positive 12m. And square of our last term, we have 9. Okay, let's proceed now with our main topic, that is solving quadratic equations that are not written in standard form. There are equations that are transformable to quadratic equations. These equations may be in different forms. Hence, the procedure in transforming these equations to quadratic equation may be different. Once the equations are transformed to quadratic equations, these can be solved using the different techniques in solving quadratic equations, such as extracting square roots, factoring, completing the square, and using the quadratic formula. Okay, let's try to answer example number 1. Find the solution set of x multiplied to x minus 5 is equal to 24. Our step number 1 here is we need to set this equation to standard form. So that is, if we have x multiplied to x minus 5 is equal to 24. We apply distributive property. So that's x multiplied to x, we have x squared. X multiplied to negative 5, we have negative 5x is equal to 24. So notice this is not yet in standard form. So we'll apply subtraction property of equality. We'll subtract both sides of the equation by negative 24. So we have x squared minus 5x minus 24 is equal to 0. After this, we're going to find the roots of the quadratic equation using any of the methods of solving quadratic equation. So in this case, I will use factoring. Okay, so we have x squared minus 5x minus 24 is equal to 0. So I will factor the first term, and that is x multiplied to x. Then I will list all the factors of 24. I have 6 multiplied to 4. I have 8 multiplied to 3. And I have 12 times 2. And lastly, I have 24 multiplied to 1. So let's try to add them. Okay, so if we'll add, we'll have 10, 11, 14, and 25. So we check first if we will get negative 5. So if not, we'll try to subtract them. So 6 minus 4, that is 2. 8 minus 3, we have 5. 12 minus 2, we have 10. And 24 minus 1, we have 23. So again, we check if we have negative 5. So we have a closer answer, that is 8 minus 3, which is equal to positive 5. So to make this negative 5, we simply interchange the sign. So positive 8 becomes negative 8 and negative 3 becomes positive 3. So when you add these two, we have negative 8 plus 3 will have negative 5. At the same time, when you get the product of negative 8 times positive 3, we have negative 24. So these are now the factors of x squared minus 5x minus 24. So we have x minus 8 multiplied to x plus 3 is equal to 0. Then we apply the zero product property. We have x minus 8 is equal to 0 and x plus 3 is equal to 0. So we add both sides of the equation by 8. Then we have x is equal to positive 8. Okay, then we subtract both sides of the equation by negative 3. So this is x is equal to 0 plus negative 3. We have negative 3. So these are the roots of the quadratic equation x squared minus 5x minus 24. So after we get the roots of the quadratic equation, we will now check, okay, the values of the variables obtained by substituting each in the original equation. So going back to our roots, we have x is equal to 8 and x is equal to negative 3. So first we substitute x is equal to x is equal to 8. So from our original equation, we have x multiplied to x minus 5 is equal to 24. So we have 8 multiplied to 8 minus 5 is equal to 24. So we subtract first those inside the parentheses. We have 8 multiplied to 8 minus 5, which is 3, is equal to 24. 8 times 3, we have 24, is equal to 24. So that means this is correct. Okay, or that is true. Next is we're going to use x is equal to negative 3. So we have x multiplied to x minus 5 is equal to 24. We have negative 3 multiplied to negative 3 minus 5 is equal to 24. So we have negative 3 multiplied to negative 8 is equal to 24. So negative 3 times negative 8, that is equal to positive 24, is equal to 24, which is also true. Okay, these values of x satisfy the equation x times x minus 5 is equal to 24. Thus, the solution set we have here is we have 8, negative 3. Okay, let's have example number 2. Find the solution set of x multiplied to x plus 3 is equal to 28. So again, the first thing that we need to do is to make this equation in standard form. So we apply distributive property. We have x times x, that's x squared, plus x times 3, we have 3x is equal to 28. So this is not yet in standard form. So to make this standard, we will apply subtraction property. So we subtract both sides of the equation by negative 28. So this is now x squared plus 3x minus 28 is equal to 0. So this is now the standard form of the equation. X times x plus 3 is equal to 28. Next step is we're going to find the roots of the quadratic equation using any of the method of solving quadratic equations. So in this case, I will apply factoring. So I have x squared plus 3x minus 28 is equal to 0. So I will list first the factor of the first term, and that is x times x. Then I will list all the possible factors of 28, writing first the bigger number or the bigger factor followed by the smaller factor. So here I have 7 multiplied to 4. I also have 14 multiplied to 2 and 28 multiplied to 1. Then we are going to add the factors. Okay, so 7 plus 4 is 11, 14 plus 2 is 16, and 28 plus 1 is 29. Notice that we did not get positive 3. So our next step is we'll apply subtraction. Okay, so 7 minus 4, we have 3. 14 minus 2, we have 12. And 28 minus 1, we have 27. So we have now positive 3 here. Therefore, these are the factors of x squared plus 3x minus 28. We have x plus 7 multiplied to x minus 4 is equal to 0. Then we apply the zero product property, wherein we're going to equate each factor equal to 0. So x plus 7 equals 0 and x minus 4 is equal to 0. So we apply subtraction property again. So we add both sides of the equation by negative 7. So this becomes x is equal to 0 plus negative 7. We have negative 7. And the next one, we add both sides of the equation by positive 4. So this is now x is equal to 0 plus 4, that is 4. So these are now the roots of the quadratic equation. X squared plus 3x minus 28 is equal to 0. Okay, so after we obtain the roots of the quadratic equation, we have x is equal to negative 7 and x is equal to positive 4. We need to check the values of the variable obtained by substituting this to our original equation. So first we'll try to use or we'll try to prove negative 7. So we have negative 7 multiplied to negative 7 plus 3 is equal to 28. So we have negative 7. When you add these two, negative 7 plus 3, we have negative 4 is equal to 28. So negative 7 multiplied to negative 4, that is 28, is equal to 28. So that is correct, no? Next is we have to prove also that 4 is a solution. So we substitute again this to our original equation. 4 multiplied to 4 plus 3 is equal to 28. So we have 4 multiplied to 7 is equal to 28. Then 4 times 7, 28 is equal to 28. It also satisfies the original equation. Therefore, the values of x satisfies x times x plus 3 is equal to 28. Thus, we conclude that the solution set is we have um, negative 7 and positive 4. Okay, let's proceed with our last example. Find the solution set of the quantity x plus 6 squared plus the quantity of x minus 4 squared is equal to 58. If you still remember in our review a while ago, we discussed how to square a binomial. So in this case, we will apply it in our last example. So if we have x plus 6 squared, if we're going to expand this, we again square the first term, that is x squared. Then twice the product of the first and last term, we have x times 6, we have 6x times 2, that is positive 12x. And square of our last term, which is 6 squared, that is plus 36. Plus, we have the quantity of x minus 4 squared. So that's simply x times x, we have x squared. X times negative 4, we have negative 4x times 2, we have negative 8x. And square of our last term, we have plus 16 is equal to 58. Next step is we're going to combine similar terms. So I will just rewrite this in vertical form. So x squared plus 12x plus 36. Added 2, we have x squared minus 8x plus 16. So x squared plus x squared, we have 2x squared. 12 plus negative 8, we have positive 4x. Then 13 plus 16, we have positive 52 is equal to 58. So again, this is not yet in standard form. So we need to make this equation standard. Okay, or we need to set this equation to standard form. So we will subtract both sides of the equation by negative 58. So bring down 2x squared, bring down 4x, and then positive 52 minus 58, we have negative 6 is equal to 0. Notice that 2, 4, and negative 6 are all divisible by 2. So we can simplify this equation by dividing each term by 2. Okay, so we now have 2x squared divided by 2, that is x squared. Then 4 divided by 2, we have positive 2x. Negative 6 divided by 2, we have negative 3 is equal to 0. So here, this is now the standard form of our given equation. Now, we will apply again any of the methods of solving the roots of the quadratic equation. So I will still apply here factoring. So x times x is x, or x squared. The factor of x squared is x times x. And if we list the factor of 3, that is simply 3 multiplied to 1. So when you add these two, 3 plus 1, we have 4. So we need to get positive 2. Then if we subtract these two factors, so 3 minus 1, we'll have positive 2. Therefore, the roots are x plus 3 and x times negative 1. Okay, so x plus 3 times x minus 1 is equal to 0. Then we apply the zero product property. So we have x plus 3 is equal to 0 and x minus 1 is equal to 0. We add both sides of the equation by or we subtract both sides of the equation by negative 3. So we have x is equal to negative 3. And the other one, we add both sides of the equation by positive 1. This is now x is equal to 1. So these are the roots of our quadratic equation. Okay, after we get the roots of the quadratic equation, we're going to verify if it will satisfy the original equation. So we'll have again the roots. We have x is equal to negative 3 and x is equal to positive 1. So we substitute first x is equal to 3 to our original equation. So we have x plus 6 squared plus we have x minus 4 squared is equal to 58. So we have negative 3 plus 6 squared plus we have negative 3 minus 4 squared is equal to 58. So simplified, inside the parentheses, we have negative 3 plus 6, that is 3 squared, plus we have negative 3 minus 4, we have negative 7 squared is equal to 58. So 3 squared is 9 plus negative 7 times negative 7, we have 49 is equal to 58. So 9 plus 49, that is 58, is equal to 58. So that means x is equal to negative 3 is one of the root of this equation. Next, we'll apply x is equal to 1. So we have um, 1 plus 6 squared plus we have 1 minus 4 squared is equal to 58. So 1 plus 6, that is 7 squared, plus 1 minus 4, which is negative 3 raised to the second power is equal to 58. So 7 squared is 49 plus 9 is equal to 58. So also we have 49 plus 9, that is 58, is equal to 58. So it means that the value of x satisfies the original equation. Therefore, we conclude that the solution set is we have um, negative 3 and positive 1. Alright, that's all for now. Thank you for watching and please don't forget to like and subscribe to my YouTube channel.